Oh, so good, Gert. And when he kind of did this, every 3 months roundup, he had a little slide that reported on curiosities, things that are there but are kind of weird. A lot of the curiosities, we experimented in V6 early on with different address prefixes for trial networks. Some listeners older than me might remember the 3FFE V6 trial network and various other efforts to try and get V6 running. And it was all just, poke it and see what breaks.
So there were patterns in the announced prefixes that people could look for, interesting quirks, odd corners of the design of use of the network space.
Who's still announcing 3FFE? Who's doing actually 6-to-4 tunneling, Teredo, so on and so forth. But one slide, he had a really interesting report. And he said, I found this curiosity. I found a route in one of the folks' BGP that isn't everywhere. It's not their route. They learned it. But everyone else has successfully unlearned it, but this router hasn't. It's a zombie. It's a stuck route.
You're listening to Ping, a podcast by APNIC discussing all things related to measuring the internet. I'm your host, George Michelson. This time, I'm talking to Geoff Huston from APNIC Labs again, in his regular monthly spot on Ping. Geoff and I discuss the Internet's routing protocol, BGP, the Border Gateway Protocol, and in particular, a problem that he's been looking at with the nature of BGP's messages and what happens when they aren't received in a timely manner or at all. BGP is how people in the business of routing Internet packets between different places tell each other what they know and listen out for what other people have to say. It's a giant rumour mill, with messages being passed down the line along paths of BGP speakers, which in turn informs each autonomous system, or AS, of what's the connectivity between things and who originates which address ranges or prefixes, as they're called. The origin AS of a prefix is the fundamental information unit passed between BGP speakers, and the path is the way that message passes between ASs speaking BGP to each other. BGP sometimes isn't able to pass on critical information, especially about the loss of visibility of a route. This failure to communicate isn't very common, but in a network of around 80,000 participating AS and almost 1 million prefixes, not very common, happens a lot more than people think. Geoff has been looking at how using beacons, regularly flashing announcements of origin in a time-clocked manner, can be used to see if a failure to pass on reachability data can be measured and what are the underlying mechanistic reasons for the failure. There are some different views on this in the BGP working group at IETF and in the operations community. We're going to have to come to some common understanding here to promote a fix for the problem internet-wide.
Geoff, welcome back to Ping.
George, it's a pleasure to be back. And yes, happy 2025. I think we're sort of into the new year. Things are happening.
They are. Now, what shall we talk about this time?
Once every year, at the start of the year, I'd look over the state of the interdomain routing system within the internet, what we call BGP, the Border Gateway Protocol.
Right, the mechanism that actually controls the reachability of all the devices in the global internet.
Yes, map maker is the best way of saying it, of how to reach every address. And it's one of these interesting protocols, certainly in terms of measurement, that instead of going out to find things, the job of this protocol is to flood all information to everybody all at the time. And so oddly enough, it's one of the few things that if you look at BGP, just your local instance of BGP, you'll find the entire internet just sitting there waving back at you, hi, I'm here. And it's actually remarkably convenient to kind of look at an instance, just one BGP instance, and go, well, what have you got? What have you learned? What's out there? And that's kind of what I do. How fast are we growing? Where do these routes come from, etc.? and try and sort of look at the state of the industry.
So this BGP state doesn't completely look the same everywhere you look. There are a few variances, but in terms of some of the scaling behaviors, how many things are you being told? How big are they? How do they distribute? What's the average length of distance between you and anywhere else? They kind of tend to a common set, don't they?
Well, the aim of the protocol is that everyone has exactly the same information. The theoretical armchair view of BGP is perfect flooding. And, if you sort of look at the spec, it sounds pretty reasonable. In reality, of course, damn reality, they don't. Everyone has a subtly different view. Now, most of the reason is because of what we call local policy. George, I don't like your routes. I'm not going to learn them. Near.
I don't blame you.
And I wouldn't say it's a Geoff and George problem, but certainly there is a fair deal of that. And oddly enough, it's all about money. If I have two ways of getting at things and someone's cheaper, I'll tend to bias my routing protocol to prefer them and selectively advertise and do whatever's needed to perform not just engineering of the traffic, but engineering of the dollars that I spend in pushing stuff around the net.
Right. So when we say everyone knows the same thing, it's as if a stone was thrown in the pond over there and we ultimately all see the ripples. But the thing is, if you're closer to the stone, you see them before I do and you see a different path, if you like. But the path variance isn't the thing at point here. The point is that it's also possible for people to put up things over their BGP eyes and say, I'm not going to pay attention to that.
Right.
So that if you look at the state that they hold and they tell other people, some information is occluded because of policy.
Exactly. So, as I said, in theory, everyone knows the same thing with local policy variations. And so the next question is, how does this happen? Now, this is not invented yesterday. The genius of BGP is actually the genius of a distance vector routing protocol. That was invented Bellman Ford. And you could date it back to the very early 1960s, before, complex networks came up. And it's an interesting protocol, the way it works. I tell you everything I know, you tell me everything you know. Full stop.
That's not much of a protocol.
That's not bad. And there are sort of subtleties in that. Do I tell you everything I know all of the time? And the early implementation, RIPE, the Routing Information Protocol, God, I love that name. I'm using RIPE. I'm with it. Don't, by the way. It's not a good protocol for today. Actually said, I'll just send you everything I know periodically. You don't need a memory, dude. You can be, as unreliable as you like, and I'll just send you a new copy all the time.
Because when I tell you things, I don't tell you the change the last time because I don't know what the last time was. I just tell you what I know now. Everything.
Right. I don't remember what I'd told you, so I can't even send you deltas. I just send you the lot. Here, blur. 30 seconds later, have it again. So when it came round to trying to get something that scaled a bit better, because, the big problem in the internet is indeed scaling.
Well, we might have as many as 60,000 routes, Geoff. We've got to be careful.
Oh, need new valves. Exactly. And so the design of BGP, Len Bozak, and I've forgotten who else was in the room, but it was a small room, evidently. It was in a restaurant. It was done on a table napkin. And one of the things about it was, I assume that you have a memory, and so do I. And that actually enabled something that wasn't available up until then, that I could just send you the changes because I know what I've sent you in the past. I don't need to tell you again. You're a computer, you're meant to remember stuff. And so I tell you something and I don't tell you any more until my view of it changes. I can't reach that anymore. So you better know too.
So we've moved from I tell you what I know, you tell me what you know, to I tell you what I know and I remember I told you that. And then if anything in that state changes, I add a thing or I remove a thing, that's the bit that I now tell you. But that then creates a new shape of the heap of things I've told you. And that becomes the view that I don't have to ever say again. I just tell you the bits that change in that.
Right. Now, there is a problem with RIPE. RIPE was done over UDP, an unreliable datagram protocol. So I might put something in my output buffer and push it on the wire, but it's IP. It's every packet is an adventure. You might not receive that packet. So me telling you something is different than you hearing something from me.
Yeah, we've explored this a couple of times talking on ping, that UDP is the protocol you use when you almost don't care whether they hear it or not, because you are never going to be told explicitly in UDP, did you get that? That's something that has to be done higher up the stack by the applications themselves. But it does create this whole things get said, they never get heard.
Now, the transition from RIP to BGP involved not just me reliably telling you stuff, but you reliably learning what I said. I need to at least assume that everything I put out, you receive. Now, you could do this with UDP plus a whole lots of stuff.
Yeah.
Or you could just ignore the stuff and go, hey, let's just use TCP, dude. Let's just use a reliable streaming protocol and put it in so that when I tell you something, TCP says, I'm going to work really hard. I'm going to deliver what you said, or I'm going to tear the session down and just blow up the world in disgust.
Yeah.
What you put into TCP, the other end will get, or the entire session will die.
So as long as we don't think about adversarial systems like a naughty BGP that deliberately throws away what it's learned, which is kind of weird,
yeah.
TCP does what we need. Everyone's a good actor. Everyone's seeking to build a picture of the entire heap, all of the knowledge. And if TCP says they got it, you don't have to worry about whether they heard you or not. It's been taken care of.
Well, oddly enough, when TCP acts some data that I sent you, that ACK is indeed a positive acknowledgement that the data, according to its sequence number, has arrived at your machine. Now, I can't tell if the application has swallowed it or anything else, but I know you've got it, because otherwise the ACK counter won't advance. So you can't drop things in TCP.
There's also a quality here, Geoff, if I'm understanding this right, that if we go through at least 3 loops, me to you, you to me to you, we both know that either end has received the data. It's not just a one-way knowledge. We both know.
Right. Now, in BGP, if you think about this, it's actually 2 streams of data. Geoff tells George new stuff. I can reach here. Oh, I can't reach there. And it's just sort of a one-way stream. And TCP is going, ACK, George has got it. ACK, George has got it. And George, because we're peers, has a similar one-way conversation. Geoff, you need to know about this. ACK. Geoff, you need to know about that. ACK. And so we kind of thought, yay, we've done it. And this was around 1989. And BGP was almost the slam dunk of routing, because it was actually then simply supplanted the gate Ds, the EGP, Hello. There's a bunch of other of these routing protocols for interdomain routing, and BGP came on and said, look, just forget it, dudes. This one just works.
People were still using RIP to flood information within their local campus networks on essentially a broadcast medium, but that's not how separate campuses, separate networks, separate entities told each other. And we were a global network of at least 60,000 routes, and BGP had got rid of all the other protocols to do this.
It caught on pretty quickly. No, it really seriously did. It was kind of the early explosion of the internet. And, it wasn't perfect, but it certainly cleaned out a whole bunch of problems, right? Now, we kind of ignored it from then on and just started piling routes in. And that was its own saga of, oh my God, so many routes. I haven't got enough memory, etc. Fine. But there were some other things about what I'd call amnesia, because BGP really had only one way of operating. Start, I tell you everything, and then I just send you deltas. Oh, could you send me everything again? No, you're not listening. We start, I tell you everything, then I send you deltas.
So you're actually saying more than just, I refuse to do that. There wasn't a primitive in the protocol to request that to be done.
The route audit.
The only way you were ever going to get everything again was basically to say goodbye, terminate that BGP session, which has wider consequences, and then bring it up again. That's all you've got.
And I suppose while it was an academic and research sort of a network through the late 80s, early 90s, turn it off and turn it on again was perfectly reasonable. What did you pay for? I didn't pay anything. Oh, well, there you have it. But when it started to assume some elements of reliability, there was this idea of, I'm not sure if I remembered everything, dude. This session's been up for 5 years. There's bit rot going on. Do you mean to say I have to tear everything down and stop routing, for you?
So tearing everything down has the consequence that you then have to tell all your other relationships, that stuff I learned from this other guy, it's gone now. You're actually actively telling people, I can't reach things, or I've changed how I've reached things.
So in the year 2000, RFC 2918 was an interesting one. It's actually called route refresh.
Yeah.
And I suppose it's kind of, I think I'm losing my marbles. Can you send me everything you've just sent me in the past? Refresh me. Bring me up to date. So now we don't have this problem anymore. We'll both be on an even par. Send me what you think you know about me, what you've told me in the past, and we'll take it from there. It's kind of a route refresh, a reset, without actually pulling the session down.
Right. There's no necessary cause that I tell anyone else I did this with you, which means I don't have to drop all the statements I've made to other people about you. I'm just confidence checking. Do I still know everything I think I know?
Yes, exactly. And I have to say at the time, there was a lot of confidence in BGP. After all the trouble we had with RIPE, even with EIGRP, even with things like OSPF and kind of this sort of synchronizing two states at a distance is actually quite a difficult problem. Do you know what I think you know? Is not an easy question to answer in kind of abstract terms. But there was a lot of confidence that BGP was getting it right. Now, at that time, we introduced IPv6. Don't laugh, it's serious.
You are not going to blame a failure in BGP on the introduction of IPv6, Geoff.
Well, this is actually really interesting. It grew by 50% in a year, and people were starting to panic about the state of the interdomain routing system. But at that time, IPv6 came along. Now, IPv6 is big. It's not 32 bits, it's 128 bits. And a simple-minded approach is you need to devote 4 times the memory to hold this stuff. Things are just bigger. And as we were kind of rolling out the first of the real IPv6 networks in the early 2000s, 2001, 2002, there was a lot of interest in, well, is it growing? Is it declining? Is this a dud? How are we going? And a very nice chap in Germany, Gert Döring, working in SpaceNet, started doing a regular report at the meetings of the European network operators, RIPE, reporting on the state of the routing table, the V6 routing table. At the same time, in IPv6, 300 routes, hardly a lot. Now, when Gert was doing this report on the state of the BGP routing tables, it was small enough that I think Gert could actually claim, truthfully, that he knew every one. He'd looked at every one of those routes and knew them. Almost a personal relationship.
Well, I can count to 2,000 if you give me long enough to do it.
200. So it wasn't exactly a challenge.
I can definitely count to 200 if you give me long enough to do it.
Oh, so good, Gert. And when he kind of did this, every 3 months roundup, he had a little slide that reported on curiosities, things that are there but are kind of weird. A lot of the curiosities, we experimented in V6 early on with different address prefixes for trial networks. Some listeners older than me might remember the 3FFE V6 trial network and various other efforts to try and get V6 running. And it was all just, poke it and see what breaks.
So there were patterns in the announced prefixes that people could look for, interesting quirks, odd corners of the design of use of the network space.
Who's still announcing 3FFE? Who's doing actually 6-to-4 tunneling, Dorado, so on and so forth. But one slide, he had a really interesting report. And he said, I found this curiosity. I found a route in one of the folks' BGP that isn't everywhere. It's not their route. They learned it. But everyone else has successfully unlearned it. But this router hasn't. It's a zombie. It's a stuck route.
So this is an analysis by someone looking in the routing table.
A number of routing tables.
And tracking down by eyeballing, because it's still at a low count and they're familiar with them. Hang on, this guy hasn't learned to change.
Yes, everyone else has figured out that route's gone. BGP, reliable protocol, get rid of this route. but this router has not. This router is now stuck, and it's not going to unlearn it until someone sends a withdrawal. But no one else is going to send a withdrawal because everyone else has actually withdrawn it. So there's not going to be a trigger to actually get rid of this zombie route, because if you didn't get the message, if you didn't get the memo to pull it down, it's never going to get sent twice.
And this is even after a replay command is issued across a peering.
Oh, no one's doing replay. The refresh only came out as an RFC in the year 2000, and no one was quite sure how often to do it, because you don't even know that you're demented.
Right. So we've got a protocol mechanism that's been discussed, it's been standardized, hasn't yet hit the engineering train of BGP, but people are already looking in BGP and seeing we might need this.
Well, Annie, as importantly, though, no one knew how often to issue a route refresh. How do you know you're missing data?
Right.
You don't. You've got no one to compare you with. Every router is autonomous. It's been told stuff. It remembers stuff. You've got the wrong stuff in there, Geoff. I'm like, says who? What's the reference point?
Yeah. Where's ground truth here? Where's ground truth coming from? Who's actually in a position to assert what you should or shouldn't know?
Well, Gert Döring, only by lifting up a whole bunch of these routing tables from a whole bunch of routers and doing the cross comparison. Why have you got that and no one else? And in this case, ground truth is the crowd, the wisdom of crowds. And if you're deviating from the crowd, you've got a problem. So he continued to report on these zombies. And at the time, it was kind of fascinating. But there was a view, and quite a reasonable view at the time, that pushing V6 through BGP was novel. It was new. And it was exercising code paths that really hadn't been exercised. And so there was a certain, without understanding why routes were getting jammed, there was a certain feeling, it's just V6.
So there was a temptation for people to ascribe the problem to a 6 specific condition, but that was somewhat short-circuiting asking the question, is this only a 6 problem?
Well, to put it in context, let me add, somewhat snidely, that there were so many other problems with running V6 at the time that one more was neither here nor there, really.
The community was willing to accept this as a plausible
totally
statement
plausible.
of why.
All the evidence that we knew about backed it up. It's just V6. Be patient. It'll get better. We'll slowly get around to fixing all these things.
Yeah.
And the other part of this was, even though the question was raised, well, if it's happened in 6, has it been happening in 4? By the time, we'd gone from 7,000 to 10,000 to 15,000 routes and ballooning, no one knew what ground truth was. No one was prepared to do a Gert and look at every last bloody route, and a number of routers across the entire V4 routing table. So the suspicion was no one was complaining. We weren't getting incidents. The routing system in V4 seemed to be doing what it needed to do. Why spend time looking for something that probably isn't there? And so we just cheerfully kind of moved on with our lives. It's an anomaly. It's weird. But as soon as you do a route refresh or a route reset, it'll go away. And certainly in the very, very early days of BGP, Geoff Rector, one of the design protocol engineers at Cisco, had the view, that BGP sessions, if they last for 2 weeks, that's a bit of an achievement. Reset it and move on with your life. And it's kind of, okay, fair enough. Long-held sessions are 14 days. Anything over that, you're kind of pushing the envelope. So when someone proudly says, I've been running my BGP session for 5 years, it's time to have a facepalm moment and go, really? Really?
Right. But that was a belief based on the state of networking in the early 1990s, when it was essentially an academic and research network. If you say 2000, we're in full spate, .com boom, commercially viable service delivery. Tearing down your network has massive consequence for your customers. So that view that Geoff Rector might have said, well, a BGP session won't last longer than a week, it doesn't actually match reality anymore, does it, Geoff?
Right. The new reality, that's why route refresh came out. The new reality was, I don't know why you think you need a refresh, what triggered you to believe that you're out of sync, but if you have that view, here's a way that you can get back into sync. And I suppose it never really got used extensively because you're never quite sure when to press the button.
Right. The uncertainty about how often to do it meant people did not instantiate any kind of regular scheduled refresh.
Right. It is kind of, I see no reason to even, think about doing this because things are fine. Why should I press the button? How do you know when they're not fine? Well, I don't, so don't press the button.
How terribly modern. If we stop measuring the problem doesn't exist. Goodness me.
That's not unique to BGP. Let me say that straight out. So we moved on a little bit and we started to look at this from a different sort of mechanism in measurement. And there was a lot of consternation over the growth of BGP from 20,000 routes to 200,000 to 500,000 to 1 million. And the next kind of problem was when we get to 1 million routes, and this is a question from about 20 years ago, will BGP be on the floor dying? Because if BGP is going to melt, we better know a lot earlier than the melt day in order to figure out what to do to get around the problem. So we need to start thinking about scaling in BGP. And there's kind of two aspects to this. One is sheer memory. Just how big does it get? But there's a second part, which is coping with dynamic change, advertisements and withdrawals. How fast, how long does it take for a new piece of information to flood around the entire network? Well, 52 seconds. Does that answer change, or has it changed over the last 30 years? Because if we're growing, and this is a distance vector protocol where messages are relayed, it's reasonable to think that it'll just get bigger and wider and longer and stuff will just get slower.
Yep. That word distance strongly implied a belief if we add more things, the distance between things on average rises because the way you add things puts them on the edge, so to speak, of a growing surface.
And so without saying what the answer would be, a number of folk, including the RIPE NCC, set up this helpful thing called route beacons. And it was a really simple approach. You announced the route for 2 hours, then you withdrew it and kept it withdrawn for 2 hours and did that forever. So if you want to know, and it's a regularly scheduled update of announce and withdrawal. So if you want to know how long it takes to move information around the world, look in your local routing table and look for these beacons and look at the time that you learned its existence and the time you received the withdrawal.
Yeah.
It won't be exactly at the same UTC time as the origination did the action. But if the gap that it took for you to get it is getting longer, then things are not going the way we want. Things are getting worse. So that was the kind of motivation behind setting up these routing beacons. And I suppose just to cut that story down, for reasons predominantly, I think, commercial, but also a little bit of the technology of the economics of cables, particularly subsea, the diameter of the internet has not changed for about 30-odd years.
So another dimension of increasing participation has changed, and that is the average number of people you speak to and where they locate.
Right. To have more people crammed into the internet, we've got denser, not bigger. So, it's the same sized internet as it always was in routing.
For the dimension of path length and delay, but there are many, many more people inside that area.
Yeah, nobody wants to be anyone's customer. They all kind of cram up to what we call the core. The distance remains the same, and oddly enough, the routing performance remains constant. So far, this is not an eternal law, but so far, this is good news. We're scaling.
So this is kind of interesting because if we've got a protocol that for some number of participants, 10,000, on average, somewhere around 50 seconds, everybody's heard the echo of a change, then if we now have a network with 100,000 and again, inside that 50 seconds, everyone's heard, the opportunistic window for somebody to, didn't hear that, has not really changed. And that kind of means to me, as a percentage quality, if there are people who, didn't get that, you actually expect to see that increasing, perhaps at a linear rate. There should be more zombies in the world.
Well, see, that was the next piece of work, and it wasn't mainstream because we were looking at the performance of announcers and withdrawals. But there were a number of folk who looked at these up, down, with the question, look, it's a downtime, dude. Why are you still carrying that route?
Why haven't I seen from you a withdrawal of reachability to that thing?
You're holding it for longer than the average of 52 seconds. You're holding it for 30 minutes. Whatever's going on in BGP has come and gone, but you're hanging on to this route. There's nothing special. There's no traffic. You haven't pinned it. You've just kind of lost your marbles. Not a permanent condition, because in 2 hours' time, an update will come and refresh that condition and you should snap out of it. But nevertheless, it was kind of an interesting other way of almost manufacturing the potential for zombies.
Without understanding why some people held on to data, it provided an opportunity for an absolutely known sawtooth changing state to be tracked. And you're saying people saw zombies in beaconed data,
Right.
not just random zombies, specific zombies.
These were zombies that we could find because, 2 hours of withdrawal goes all the way around the network, except for the folk who have managed to wedge themselves and go into a dud state. Don't know why still. Don't know why, but kind of easier then to figure out how big a problem this is. It's not a big problem. It really is an anomalous way of operating, but speculation as to how started to occur. And there's one speculation that kind of goes, modern day big routers are almost like data centers in a box. The data paths are extensive. Where a route is held is not it's held here. It's held in every single line card. It's held over in the
Yeah. We have a mental model of this thing, the RIB and the FIB, the routing information base and the forward information base. And if you're a computer scientist, you imagine them as continuous extensive memory built as radix trees.
Yeah.
And the truth of a router is they're placed where they need to be by the architecture, and that is not a single structure.
Right. And the router has finite sort of resources. It's operating in panic mode. Messages are flying all over the message bus.
That is such a lovely image, Geoff.
Well, it's true, though. It's kind of, this is the way they operate. They're just below chaos. And, it's remarkable they're as reliable as they are. And one theory is, in some ways, stuff just slips through the cracks. When you can't write linear concurrent code and you're writing stuff sitting there in multi-threading, most humans' brains just collapse. It's really hard to think that way.
Slips through the cracks. I think I'm going with shit happens.
Yeah, it's the same kind of stuff. It's just oh yeah. And I suppose the other reason why I'm being slightly dismissive about it is if you can't remotely cause a route to be jammed, and we don't know how to, we can, it's not a threat. Yes, you can beacon a route up, down, and there's a higher likelihood that it may get jammed. But if I want to take a route to my network and in your router turn it into a zombie, I can't do that. I can't, as sort of a remote person, try and trigger this. So it's a very hard thing to exploit to be bad or annoying. It's just interesting artifact.
It's a thing that we can see, and it's unpleasant to be aware that there are constructed states in this global information space that aren't correct, but they don't yet appear to apply to routes of major significance. So the whole of AT&T's North American routing surface does not magically get wedged because of a zombie state and no one in Europe is able to reach them. That sort of situation doesn't seem to be happening at scale because of zombie routes.
Right. So how do zombies occur? Now, like I said, I've given you what I'd call the conventional view. It's a complicated router out there, son. Things just happen all over the place. Yeah, sometimes a marble slips out and drops to the floor. Meh. There is another view. How long does it take for TCP to send a packet?
That's the layer beneath BGP, sending BGP messages.
It's the transport protocol. And let's assume that you have not enabled TCP keep alives or anything like that. Just vanilla, simple TCP.
So for those who aren't aficionados of protocols, keep alives are when you send the minimum amount of information across links to say, are you still there? We sometimes see them in things like SSH sessions where SSH will randomly say, yeah, you're not using this terminal. I think I'll go away. And you drop your SSH binding. And there's actually a configuration option, turn on SSH keep alive. So the idea of sending a periodic, yep, still here, got nothing to say to you, here I am, don't forget about me, is built into protocols, but you're saying they're not always turned on.
Well, no, but it's there because the underlying mechanism of TCP doesn't have it as an intrinsic part of the protocol. You could take I was going to say the wire from my laptop, but it's Wi-Fi. You could drop the connection somehow, literally drop it, sever it, do what you need to do. And as long as you don't change any addresses, change nothing, come back in 3 weeks and rebuild the connection, the TCP state that was active at the time you broke it would just restart.
As long as you haven't done any kind of keep alive behavior.
Right, as long as you haven't done any other intrusion. In other words, there's no set time for TCP to do anything. Keep alive actually is not a timer on sent packets. It's just, are we talking? And without keep alives, TCP has no, are we talking?
Yeah. TCP exists as the state held in the two machines that want to talk TCP. I know the last thing you said. You know the last thing I said. I know your window. You know my window. I know your address. You know my address. That's all you need to know. Go away for a month, come back. If you still know that, you can carry on like nothing changed.
You're fine. So if you ask the TCP session, are you talking? The answer is, well, I guess so. Give me data and I'll send it, but so what?
Problem with that world, Geoff, is that if I quietly took off my headphones, got up and went away, and you have your eyes shut and keep talking, you don't know I've gone unless at some point you necessarily have to do a, did you get that?
Hold that thought, George, because we're going to get back to that thought because that's the topic after the next one. The first topic I wanted to talk about is TCP intrinsically does not manage the liveness of its connection. Like I said, you can walk away, come back hours later, and TCP would go, yeah, dude, I'm ready. I've still got state. You haven't rebooted. We're fine. It's actually up to the application, SSH keep alives. It's up to the application to actually periodically send data inside the TCP stream to kind of confirm that stuff's alive. And the way BGP gets around this problem is that by default, every 60 seconds, BGP schedules effectively an empty message. It's called a keep alive. And it doesn't even carry any data. It's just keep alive. And at the other end, because all BGP sessions are bilateral, A talks to B talks to A, you just look for, you have a little, I suppose it used to be called a dead man's timer. I'm not sure what the political right word is now. Are we allowed to still call them dead man's?
That's a different ping conversation. Let's not go there.
Let's call it a liveness timer and just get over the entire problem. But the issue is, I expect to see an empty packet every 60 seconds.
So you have now put a literal time count on the table here.
You can change it in config, but the default is 60 seconds. And so the issue is, if I don't see any such packet in 180 seconds, 3 times, I assume this connection is a dud. And I tear it down and start again from fresh or whatever. I tear it down. We are not talking. In other words, liveness in TCP is an application attribute. It's not intrinsically a transport attribute. And BGP kind of has this liveness test.
So not wanting to go too hard to what mandates mean in practice, do people in global BGP right now use keep alive routinely? Is it negotiated as a behavior between BGP peers normally now?
It's default.
Right.
By default, it's 60 seconds with a 180-second timer. You can drop that number. You can drop that number to 0. But quite frankly, in terms of risky, stupid practices you shouldn't do when adults are around, dropping it to 0 is one of them. Keep your hands off that knob. And by all means, if you want to make it more responsive, you can drop it down. And there was a fashion for faster BGP to drop it down to try and emulate the telephone networks at 50 milliseconds response time. But the issue was any kind of queuing or jitter had this potential of triggering it's dead, dude, and triggering unnecessary resets. Bad idea.
But nonetheless, default behavior in modern BGP speakers, the application will periodically keep a live signal bilaterally across a link if TCP, to its knowledge, can't send packets because the other end state has got out of TCP whack. You're going to know.
You're going to know because you're not receiving the packets from the other end. I can't tell if I'm dead to you. I can't tell if you're receiving my keep alives or not. But if I don't receive keep alives from you, you're dead to me. And I react to that. So now let's talk a little bit about zombies. And as I said, one theory was it's just, if you open up the router, it's pretty bad. It's very, very complex. Things just get lost. Or you could say, hang on a second, maybe there's a particular type of jamming that is happening in the underlying transport session. Now, let's say that you put down your headphones, listener or George or anyone else, and just walk. Don't do that, George. Don't do that. Put them back on.
Sorry, what did you say?
Yeah, you just walk away. Now, in TCP world, what will happen is stuff will start queuing up. It'll start queuing up in your receive buffer, where you say, oh, I'm storing stuff for the application to come back and get it. I now only have space for another 1,000 more bytes. And I send you some more and you go, oh, that was really cool, but I haven't really processed the last lot. I've only got space for 20 more bytes.
So you're sliding the window shut as the layer above you refuses to drain your buffer. And you
to drain the buffer. And at some point you kind of say back to me, no more space, dude. I'm full. The application hasn't drained me. You can't send me any more data. Receive window equals 0.
But that state, Geoff, doesn't mean I have to can the TCP connection, does it? It's just that I've told you I can't hear that.
No, it's still live. Right. In fact, what I do then at the TCP level is keep on receiving data from the application until my send buffer fills. So we start to build two queues, one in the receiver not processing and one in the sender waiting for the receiver to drain its side.
But this is purely in TCP. The applications, to some extent, don't have overt consciousness because TCP doesn't have an instrumented state of saying up, can't send, or didn't receive. That isn't quite how it works.
Isn't there? You don't know. And let's say, for example, that this happens on the sending channel, that it's blocked at the other end, receive window equals 0, but over at the other end, it can still send. That's, full duplex, that's the other path, and I'm still listening. So from my point of view, I'm getting regular keep alives. You're alive. The fact that I'm finding it very, very difficult to send you data because your end is full, receive window equals 0, my buffers are full, doesn't stop me from believing that you're alive because you're still sending me keep alives. That's a really odd state. And the answer is, yeah, it is.
It feels like a condition which ultimately would wind up in BGP getting its knickers in a knot. It feels like it should ultimately percolate into the application space and have the application say, I really have a problem at this point.
It feels like that because what's going on is, A, you can't even receive my keep alive messages. So if you're not a complete zombie, and I mean just balked, you should be triggering your keep alive alarm because you haven't received anything from me. In essence, I've been trying to send you messages, but you have not been receiving them. You can send, but now you're seeing the keep alive flow should have stopped. Within 180 seconds, you should have turned it down.
Which would have been globally visible as a withdrawal of all routes acquired across that association.
TCP reset. I'm out of here. TCP reset. We both know it's all dead. Let's start again.
We are in the unfortunate position. The consequence of this is globally visible in terms of a drop of a route, but nonetheless, you wouldn't have zombies because you've reset to ground state.
Well, if transport is the cause of zombieism, then yes, you wouldn't have that. But, like I said, what's going on, if you think that transport causes zombies, then you've got this strange view that the other end in a jammed transport session is willing to press on while not receiving keep alives from the other end. It's kind of wow. And what actually goes on is not just a zombie, your entire set of routes learned from that peer is now not changing. Nothing changes. No updates, no withdrawals, nothing. The longer it stays in that state, the more out of sync that adjacency view falls. Okay, so now that we've kind of posited a theory as to why this happens, and it's just a theory, then it's a case of how can you find it? How can you see it? Now, with routing beacons, you kind of know what to look for. You know when it's up, you know when it's down. But in abstract, if I take a routing table, even if I look at it over a period of take a snapshot, or even look at the updates, how do I know that a route in a routing table is a zombie? If I look at one routing table, give up. You haven't got a hope. I actually need the BGP panopticon. Thank you, Jeremy Bentham. I call in this weird view that says, if I could see every BGP session all of the time, then I can find zombies. I can.
So for students not of history, Jeremy Bentham's panopticon was his idea of what a jail should be like. It was a round building with all the warders in the middle looking into the rooms of the prisoners surrounding it, making sure that they were being industrious people, picking oakum fibre, turning handles in sandboxes, working on cranks. Nothing was hidden.
The Americans actually built a few.
Strange person.
Bizarre. I find it's very weird. Jeremy Bentham, normally should not have been remembered by history. Strange person.
Lives in a glass case in University College London and is carried into Senate meetings to be present at all times. But the thing is, we don't have a BGP panopticon, do we, Geoff?
George, my jaw is still bouncing off the floor about his treatment as a glass cage and being wheeled in. But yes, we don't have a panopticon. But if you did, if you see a route that has an AS path, the path of where I came from, saying, I was handed to me by A, who sent it to B, who sent it to C, who sent it to me. Then because I've got the panopticon, I can ask, C, have you still got that route? B, have you still got that route? A, have you still got that route? And if the answer from A is, no, I withdrew it months ago. B, likewise, I heard it from A, I dropped it from A. C says, B told me to drop it, and you're still carrying it. The answer is you're a zombie.
Right.
You've got that zombie route. So if you had universal panopticon vision in BGP, you could find this stuff.
Right. Can you come close to it by using a set of views of BGP to get a level of exposure to what should have been seen by a group of people if you have enough points of measurement around the state?
Yes, but, our routing views, our route collectors number in the hundreds. The number of ASs is getting close to 100,000. The number of routers is well over the million. This is the scaling problem. We have not got that degree of vision to nail down such a view,
right,
to test this theory. So, okay, you kind of go, well, yeah, right. But there was a response from a couple of folk who'd looked into this. And it was an RFC that came out in October last year, RFC 9687, which was actually a piece of protocol work to say, there is a failure going on here about BGP does keep alives, but it doesn't do link liveness. It doesn't really say, is stuff moving? Why don't we do a new timer called a send hold timer? And that's RFC 9687. The idea is that if my sending queue starts to jam up and I'm unable to drain stuff, then the send hold timer will trigger. You've got stuff that's been waiting to send for my default period, a minute, 2 minutes, 8 minutes, whatever, a period. And if that isn't cleared, bring down the session because you're just in a weird state, right? You're unable to send stuff. And you kind of look at that and go, oh, yeah, it's possible. That could work. But I must admit, I was trained in classical networking practice, being around for a long, long time, sliding window protocols, etc. And this strikes me as an odd answer. Applications normally don't have a view of the underlying TCP machinery. So to say simply, I reach down and look and see if my sending queue in TCP has moved or not, the answer is, but how, dude? What's the API?
Yeah. In order to gain that knowledge, you have to do two things. Firstly, you have to code yourself to have points to ask the introspective question and act on it. And secondly, the operating system or the user space protocol stack has to be changed to be able to supply that answer. You need a porthole into the system to obtain that information.
I need to do a layer violation, and a pretty bad one. And it's not going to be given for free. There's work going on to actually do this. So you need a lot of control of the stack and the environment as much as BGP itself.
So this raises a question in my mind. I mean, mandatory to implement has the quality of the word mandatory that I don't particularly like in standards anyway, because it's all voluntary adherence. There's no protocol police here. But is this something that is now strongly recommended to be done, or is this a design element that is still under discussion to actually appear in people's live operational code?
I would put this in the kite flying exercise. Even though it's called proposed standard, it's come out and got given an RFC number. I don't think it's a very good approach. I actually don't think it's good protocol engineering. And I would certainly say there are better ways of doing this.
So what are the alternatives that you would see for achieving this outcome?
I suppose the first thing to understand, and it happened with the transition from 16-bit to 32-bit autonomous sequence numbers in BGP. BGP negotiates capabilities on opening. Hi, dude, I speak 32-bit ASNs. Do you? The answer you give will affect what we do. You're right. BGP will actually... So you're able to do a lot of things incrementally as part of this negotiation. So let's posit a different way of doing things, and let's attach a payload to the keep alive message.
So this is change in BGP's messaging, no necessary change in TCP.
No send alive, send hold timers, anything like that. It's just a change in keep alive. I do extended keep alive. Do you? If you do, let's sing and dance.
So what would extended keep alive mean?
Well, I invent a number, a value. Let's say I'm using 32-bit keep alive token values, and I just pick up a number, any number at all, and I stash it in the sending number field of the keep alive. Now, the keep alive, the extended keep alive, also has a second field of what I'd call the receive number. So you and I are now exchanging keep alives. And after the initial exchange, I now have a most recent number that I've seen from you, and I send my current number and you're the recent number that I've received back to you.
Right. So by sending both what I'm asserting and the last thing from you I've seen, we both get to know what both ends think is current. Not just have you seen me, but I know you didn't see me is kind of latent in this mechanism.
So you could think of that token value as a count of seconds, monotonically increasing. It jumps, with every time I send a keep alive, which means in standard sort of terminology, it might jump by a value of 60 every time. Doesn't really matter. As long as it's monotonically increasing, always goes up.
As long as it's increasing, it's never going backwards.
Exactly. And you just send me back whatever I sent you. Then if we've got a break, if we've got a loss of liveness, instead of seeing back as the number I sent you, 1, 2, 3, 4, 5, I start to see 1, 2, 2, 2, 2, 2, 2. It's kind of, oops, my messages aren't getting to you because I'm now up to 10 and you're not sending me anything, dude, that reflects that. You're just sending me 2s. We've got a problem.
Yeah. And it's a strong inference that the reason you're sending 22222 is that the TCP window jamming state is preventing somebody's buffer from draining. Windows have locked down, but TCP hasn't shut because it doesn't need to. It's simply sitting there saying data isn't being processed and no data is flowing. But this other message is passing through.
So in essence, I'll see your messages back to me and they reflect that my messages aren't getting. I'm still incrementing my timer and stuffing more keep alives into the send queue, but it's just not working. That kind of extended keep alive, and this is not new to Geoff or BGP. This is really, really, networking AO1 based stuff. Token exchange is a really sturdy method of link liveness.
So the things I find attractive in this are that it's a negotiation between BGP speakers, so it's respectful of knowledge of BGP doing its thing, which means it's also incrementally deployable, and absolutely no layer violation and no need for a new API to talk to TCP locally to interrogate it about metastate. You don't need to change the software stack.
Right. So it kind of extends keep alive to the bit that was kind of missing. Not just I'm getting messages from you, but it actually adds this added bit, and you're receiving messages from me because of the rising token value of my token. So, with that simple enhancement, I've then got, I think, all of what the send holder timer was trying to do and more. I know because my constantly updating value is being echoed back to me you're getting at the BGP level my messages. You're getting them. What you do with them is your business. But I can see, in echoing back the token value, that your BGP session is alive and seeing my keep alives. And that's a good thing. And it kind of argues to this idea of when you take a very, very mature protocol, and at 30 years old, maybe getting close to 40, BGP is no youngster in the block here. Adding more frobs and buckets and levers and dials and so on, be careful. Be extraordinarily careful. Be gentle. Don't immediately leap to a new feature. Try and understand exactly what you're doing with that protocol and try to do it gently in a way that kind of, I suppose, fits with the underlying design principles of the protocol you're working with. Be nice to it, and do changes sympathetically that don't kind of introduce complexity, new failure modes, and new ways for operators to get things wrong. Try and do it quietly.
Is this a conversation that has to go into IDR, or is this something that you think you might be sitting back on and letting other people pursue? How active do you think you need to be in this?
I think my time of struggling with the IETF process to write an RFC, which, requires a degree of energy, implies a degree of process sort of tolerance, is very stretching for me.
Not going to happen for you, though.
And if someone who hears this goes, time for an RFC, I would wish you Godspeed and go for it. It's not hard. It's not me, no, but, the idea, and it's not even my idea. This is very, very conventional network protocol engineering. It's just standard techniques.
We're going to have to keep an eye on this, Geoff, and see what the surface of deployment is for the new send hold timer feature and what measurement of zombies exposes in terms of this problem at scale. I think there's more measurement potential in this question. The critique of whether their approach is right or not is certainly part of it, but I think the fundamentals here are we need more observatories and we need more points of measurement in BGP if we really want to understand this stuff.
It certainly doesn't do any harm, George, but the other part of this is it's fine to build the tools. You've got to look at the data. And, the enthusiasm of let's build another collector, let's build another one of these. I'm like, right now, the problem with so many route collectors is that the amount of machinery you need to devote to pick up all the data from all the route collectors and then apply all the analysis rules against that data is certainly not one that you can do on a tidy little, home machine with limited processing ability. You can't. It's just the ante's gone up and up and up as the data sets have risen. So we need more is something that maybe is not necessarily true. It's more, let's do better with what we have and figure out what we're missing rather than just, more is better, because that's not necessarily true. So I'm not advocating for 1 million route collectors. I'm really not, George. We wouldn't know what to do with them.
Watch this space, people. Let's see what emerges. Thanks, Geoff. That's been fascinating.
A pleasure. And dear listener, thank you for hanging on. Cheers.
If you've got a story or research to share here on Ping, why not get in contact by email to ping@apnic.net or via the APNIC social media channels. Also remember the measurement at apnic.net mailing list on Orbit is there to discuss and share relevant collaborative opportunities, grants and funding opportunities, jobs and graduate placings, or to seek feedback from the community on your own measurement projects. Be sure to check out the APNIC website for all your resource and community needs. Until next time,